I'm gonna hit share screen. Well, thanks guys for jumping in, and I look forward to just sharing with you a little bit more about this data-driven topic. It's one that I'm kind of a nerd about. I use this almost every day in my job, and I think it's a very this is a very approachable way of looking at data, and I think if you want to, you'll be able to pick this skill up pretty quickly. So let's just kind of jump into it. My goal is to answer any questions that you have, and to take sort of a simple approach, like the most simple way of describing kind of a programming language. So I'll give you the minimum, and if you want me to get a little bit more in detail, if you have a specific question, don't hesitate to either put it in the channel here for the group chat, or just unmute yourself, and I don't mind. I don't mind at all. So I've got a little deck here. I'm going to walk you through that. The agenda is basically talking about what is SQL, and how does it work, in the sense that, how might you as a aspiring data analyst, how might you use SQL to understand data? And then also, how might a web application use SQL to interact with data to create a web experience? So this is not an engineering conversation, but we will talk about some really core topics that you probably hear about in our little tech company, during the stand-up meetings that we have. So we'll talk about structured data. We'll talk about database operations and this concept of CRUD. We'll talk about some different types of data and how APIs would be used to, again, explore data from a web app. So what is SQL? And sometimes I call it SQL, sometimes I call it SQL, but it stands for Structured Query Language. And as I wrote here, it's a programming language like PHP or HTML or JavaScript or any of the other languages, but this language has the not unique, but the specific task of interacting with databases. And not just any database, but these structured databases where you have data that falls into a standardized format, such as when you view a report, like on referrals, or when you see a sheet or a graphic in Click, you might be looking at things like the CPL values, or the submitted date, or is bought, or any of the other fields that Leads API collects and then stores in this kind of in this database that is hosted by Redshift. So structured data is kind of not the language of SQL, but it's a specific format of data, as opposed to unstructured data, which would just be storing blobs of text and other things. So SQL is a really common database operation language. It's not the only one, but it's super common. And then MySQL is this database administration program that uses SQL, where if you have a database, MySQL you can use SQL to interact with that database. So let me make this a little bit more concrete, and I'll show you some examples of SQL. But before I do that, just to make it a little bit more obvious for how common, how ubiquitous database and database operations really is in the marketplace. I went to monster.com, and I was looking through the job listings, And I was trying to understand, what are the most common languages? And this is not like an exhaustive list of languages, but it represents kind of a variety of job tasks, of database tasks, or programming tasks, or other things that you would do it from a sort of technical perspective. So this is a descending list. So as you can see at the very top, with this very commanding, this very large chunk of jobs that are listed on this one job site, SQL is far and away one of the most popular things listed in a job description. So this isn't some abstract thing that isn't used by anyone except for super nerds. SQL is something that a lot of people are using, from data engineers to data analysts, or other people who need to go and look through data to understand it. So employers are looking for folks that have this skill. I think, as I said before, it's super approachable. So it's something that you could learn either on the job or in your own free time. And when you compare the number of listings here to something else like C++ or PHP, you can see that it's a super popular language. So what does it look like? What does it look like? I just took a screenshot of a database, right? This isn't SQL, but this is a MySQL database, and I'm using this program that I'll show you in a moment, called SQL Pro. And what SQL Pro does is it uses SQL and this graphic user interface, this program, so that you can visually explore MySQL data. And this database has a lot of the fields that you would probably expect for a table of reviews. So if you go to retirementliving.com and you leave a review, then your review will end up in our database, and it will look like this. It will end up becoming a row in what's essentially a spreadsheet. And this is by no means the only way that a database would look, because the data is going to be different depending on what users enter into it, obviously, but also the structure of it. So our reviews, they're comprised of ratings and reviewer IDs, which is the ID of the person that left the review. And it also has a company ID that's associated with the review. And if it's published or not published, that ends up becoming part of the status column. And as you can tell here, the columns give meaning to the data, and then the data itself lives in these rows. And this could be anything. It could be any type of data that you want to store. Could end up being a column in a database. So are you with me so far? Good, I hope so. You already know how SQL works. That's my point here. If you've ever seen a spreadsheet, then intuitively you understand what exists in one of these SQL databases. So in spreadsheet language, we are concerned with tabs, right? You have a tab for one type of data, a tab for some other data. SQL is the same way. In a database, you would find many tabs, but we don't call them tabs. We call them tables. So you have tables that exist just like tabs in a spreadsheet. And all of those tables together, made up of their columns and rows, that is the database. So we call the columns in spreadsheets columns, and we call them columns in SQL databases as well. And then what we call rows in spreadsheets, we call records in SQL. So actually, my arrow here is the wrong direction. So what I meant to say is we call rows, data points in spreadsheets, and these are records in databases. So that's how it looks. And if you're actually using SQL to interact with one of these databases, you can use that graphic interface like the one that I shared with you. But essentially those GUIs, they write the SQL for you. And almost all of the database operations that you would have to do, whether you're a web application or a GUI or just a user, most of those operations fall into these four types. And so it's so common that we call it CRUD, which stands for create, read, update, and delete. And of these four types of database operations, almost all of it, especially from the analyst perspective, almost all of it is going to fall into this one category of read, where you're using SQL to look through the database and to find the information that matches your criteria. So this is the syntax, and these are just example queries that I made up. But as you can see, there's a lot of common, there are common themes between each of the facets of CRUD. But in CRUD, for the create, essentially what we're doing is we're adding new rows to database. So it always starts with insert into, and then we have a name of a table, and then the values that we're inserting in this parenthetical statement here. So every time that you're creating data, you're going to insert into a table with specific values. If you're reading data, then you're selecting columns, and this asterisk here just represents all. So we're selecting, in this case, all columns from a table called invoices where the date is greater than 2019. So if I wanted to do all invoices from 2020, then I could write this query. Update would be taking an existing record, but then changing it in some way. And it always looks the same. Update, here's a table name. So I could update the invoices table, and I would maybe, for instance, set an amount equal to a new amount where the ID of an invoice equals 2221 or 2291. So if my previous invoice value was say 8,000 and I knew that was wrong, it had been entered in an error, then I could write this statement and I could update that specific invoice number with a new amount. And this would be much less common than a read statement, but records are constantly being updated, especially in web applications. And imagine that you have a listing of usernames, and those users have passwords, and the passwords are stored in a database. Then as a user, I might want to go in and update my password, and probably at some level, a web application would be doing something like this. It might, that web app might say something that says, update user database, set password equal to my secret password where user ID equals SWrite, or the number that represents my user, like number 2. So that's an example of an update statement. And I'll show you more about what that might look like in a few moments. And then delete is always the same. It starts with delete from a table name where these are the conditions. So if you look at the anatomy of an SQL statement, it's quite simple. So think in CRUD language where the first word is describing what we're trying to accomplish or the type of operation. And then this second feature of an SQL statement is just especially for typically for a select statement, it would be which columns are we trying to select. And as you can imagine, again, based on the many ways a database might be constructed, that could be anything in this second item here for an SQL read statement. And it would be a comma separated list if I wanted to only select a few of the columns. So I might say select ID, comma, invoice amount, right? Um, but star is a really good one if you're trying to explore data, because then we can see all of the columns. And if we're then trying to further narrow down the size of our query or the scope of our query, then we can start calling out specific column names.
Hey, Stephen, I'm going to jump in. We're coming up to the time that we had on the calendar. So if anybody does have a hard out, we're recording and I'll share it in the Coffee with channel, but we'll keep going if you guys are able to stay.
Sure. What time are we done at? Are we done at 10 or 11 your time?
Yeah, I think the calendar invite said 10:50 technically, but if you don't have a hard out, then we'll stay on.
Okay. So yeah, there are some different types of SQL data, and this is not a comprehensive list, but we could store everything from string data, which looks like maybe a user's name, to integer data, which is whole numbers like 120, Boolean data like true or false. We can store timestamps. We can even store blobs of HTML or other forms of text. So all of those types of data could be stored in a database. And just to make this kind of concrete and interactive, let me show you how I would explore some review data and to do these specific types of tasks. So the first thing that I want to do here is read all reviews. So I'm going to write some SQL to just look at the contents of my reviews database or table in the database. So this is our production retirementliving.com database, and it holds all kinds of things from comment information that users leave behind to post information for the posts that are in our website, and then also company names and the IDs and other information that we store about companies, and then of course reviews as well. So if I want to look at all the reviews, then I would be writing a CRUD read statement, which is using the select operator. So you could say select all, and then from, and I'm going to say the table name, which is RL review. I want to match that exactly in lowercase. And if I end it with a semicolon, then I see all of the reviews that are left. And they're listed in order by the ID and by default in this ascending list. And it kind of grows from here, right? That's not a super helpful query, but maybe I want to find out what are all the reviews about one company, like Sears Home Warranty. So if I know that the company ID for Sears is 27, then I could add this where clause. So I could say where company underscore ID equals 27, semicolon. And if I run that, then now I'm getting a subset of all the reviews, and these are only the ones that are for Sears Home Warranty, right? So getting a little bit more helpful. And what if I wanted to find out all the tea on, if you will, on Sears? I want to read the bad reviews, and I could add an and clause here and say and rating equals 1. So if I do that, I'm looking at all the 1-star ratings. And because consumers don't really like to say nice things about Sears Home Warranty, we have a lot of 1-star reviews. So those are all the 1-star ones. And I could add as many operators as I want to here in the same fashion and just further, shorten this list of results. But what if I want to do something like, say, for instance, count the number of reviews? And that is all reviews, not just the ones that are 1-star reviews. So I could do that too. Maybe you would have to export this into a CSV file and use some Excel function if you're trying to do this with some kind of data dump. But with SQL, you can do that kind of operation super quickly. So I could just use a count statement. So if I say select count ID, from RL Review, where company ID equals 27, I have 670 reviews stored in retirementliving.com for Sears home warranty. So did you see how we can really quickly dig into data and understand it a little bit better? It's a really powerful language. So what if I said, let's count all the 5-star reviews? Same kind of thing that we were doing with the read statement, where I would just add another clause here. So I could say where rating equals 5. And I see here that there are only 12. So we're really easily able to digest information in a database with this powerful language. Let me show you some really cool stuff for like aggregating data. So if I want to see the distribution of Sears reviews, rating 1 through 5, then I could do something like this. Select rating, and then I would count rating from that table where company ID equals 27. And then I'm going to add a group by rating. And if I do that, then I can see for a 1-star, 2-star, 3-star, 4, and 5, how many ratings we have from each of those. Wow, guys, what? I don't have to go in and create some Excel function to do this where it's count if. No, you don't. It's much simpler than that. And all the same operators that I was using before, I can use, like if I wanted to do an and statement and just limit this to a specific year. So we're published date is greater than 2019. I'm looking at not just for Sears, but for all companies greater than 2019, seeing the distribution of ratings. I could even do something like an average rating for during that time period by rating. Or if I wanted, which this makes sense, of course, the average of 1-star reviews is 1 star. But if I drop this group by, oh, hold on. Boom, now I can see during that time period, I have a 2.3 average star rating on the site for all these reviews. There's a lot of really, powerful data aggregation type stuff that you could use SQL for. And you know what, I'm out of time. I could really get more into this, but let me share a couple things with you. I made this little demo website so you could actually see how a web app would interact with data. So this is in the Coffee with Slack channel notice that Sam sent out. But this is just a list of some example data based stuff and how a web app has spit all of that out. And at the bottom here, you can see what was the SQL language that I used on this page to then get these results. And if you go into any of these individual ones, then you can see how this is a more specific select statement where the ID of this invoice is 13, and I am actually pulling all that records information and putting it into a form here. And I could even change this and take a look at what the update SQL might look like. And all the code that I used for this web app to create the database language is in this public repo. So if you were interested in checking out how a web app might write SQL on your behalf, you could look at this this file and this repo and get a feel for how CRUD is used by web apps.
Yeah.
I think I got 1 minute left. What questions can I answer for you?
If no one has a question, something cool, just to even know about, now that you know a little bit more of the back end stuff of it, this is one of the big reasons we had to get away from Looker. So what happened with Looker is you would go on, you'd have Looker and you'd say, show me all, TV leads that came in on this date. You're essentially using those fill-in boxes to write a SQL query. I want to select this
Exactly.
from here, from here. So what happened with Looker was that every single time you put something in one of those boxes and said, run this for me, it was hitting those databases. And everything was
Hmm.
SQL, even if you put something in a different order, because it'll search based on the order you put stuff in. So if you put something in a different order, you're going to get a little bit different data than somebody who thinks they're doing the exact same search, but it's slightly different. So that's why we were having a lot of issues with, I'm running this search and getting this data. I ran the same search and I'm getting different data. Why is that happening? So that was one of the big deals we were having with Looker. And each time you ran a Looker query, it would hit the database over and over and over again. So it'd have to look through the entire database, filter it through, and it would break like 2 or 3 times a day. So with Click, what we did was took all those databases, threw them into Click, pre-programmed the way you can see everything. So that's why it's a little bit harder on the setup side, because we had to set up everything to begin with. But then everybody's seeing the same accurate data and we're not breaking the database 3 or 4 times a day. So it's essentially, and now that you know a little bit more of SQL, that hopefully makes more sense as to why we needed to make that switch and why we'll have to build tables to do joins and things like that to get your data where it needs to be. But I just thought that was a good opportunity to kind of explain why we
Yeah.
need to leave Looker to Click.
Well said. And in the cases where a Click report or a Looker report doesn't do what you need it to, there are tools like I use Mode to make my ad hoc reports, where I can actually just write the SQL myself and then create the reporting that I want. And so it's just going through those databases, those database tables, and you can do with Mode, you can do pivot tables or columns or other things where once you've selected the information that you want, this is from our referrals database, then you can, without using SQL, you can then make these more digestible charts and other things. But SQL is the backbone of what's happening inside Mode. And this is a tool that I just absolutely love and rely on every single day.
Yeah, and like he said, it's insanely easy to learn. I didn't ever know what SQL was before probably March, and now I'm coding out jobs for pretty much every department in the company. So it's relatively easy to start up. It's just all the tiny little nuances that are hard. So if you are interested in learning a coding language, this is a very, very good place to start.
Yeah, absolutely. And W3 Schools has a lot of really useful um, and interactive things that you could use. But because it's so popular, because it's so easy, as you said, Sam, I think this is a great way
Sure.
to pick up a technical skill that you could use on the job.
Well, thank you, Stephen, so much for really going above and beyond on the presentation here. We really appreciate it. We'll go ahead and
Of
hop since
course.
we are over time. If anybody does have any additional questions or follow up, we will be available in the Coffee With channel.
All right, guys.
Have a good day, everybody.
See ya.